now.
All right. Hey, folks, thanks for joining us today. This is Josh Roloffs, the product manager here at Wholesale Solar. We're here with Primus Wind Power to talk about wind, solar, hybrid, off-grid systems. We've worked with Primus for a number of years, really experienced with the product. They're made in the USA. We have Ken Kodelik from Primus here today. Ken's going to tell us all about wind, solar, hybrid systems. Could you go ahead and go to the next slide, please, Ken? Be sure to stay tuned for a special offer. We're going to have a coupon code at the end of the webinar for all Primus wind turbines, so stay tuned for that. And with that being said, I'll let you take it away, Ken.
Well, thank you, Josh. I appreciate it. We certainly appreciate Wholesale Solar and their experience in the market, as well as their dedication to education of our customers on wind and solar and hybrid and the best off-grid system that we could possibly produce. So let me tell you a little bit about the agenda today. It's actually going to be about 45 minutes long. The last 15 minutes will be for questions live right here on the webinar. But I'm going to give you a quick overview of the company and a brief history of the Air product line, which has been around for over 25 years. Talk about turbine types and the different applications, the different turbine types we have. Wind 101, so that would be siting and towers, just explaining how this all works. Operation maintenance and hybrid systems, installation, determining a wind resource, why hybrid, why off-grid, why it makes sense to combine the two together, why that's so important for specifically an off-grid system. And then we'll end with some examples of pictures of different applications. And then the Wholesale Solar special offer that they're going to be offering to you guys as an incentive to check out this idea of the hybrid system. So Primus Wind Power is a division of Primus Aerospace. We're based out of Denver, Colorado. We purchased the airline from Southwest Wind Power in January of 2013. We did not purchase Skystream or Whisper, if you remember those two product lines that Southwest Wind Power had. Our parent company, the aerospace side, is a precision metal manufacturing company for Lockheed Martin, Department of Defense, NASA, etc., aerospace stuff. So it was a logical offshoot for a wind turbine company to be part of Primus, the Primus umbrella. We produce, manufacture, engineer all the turbines right there in the Denver factory. So we're very proud of the fact that our turbines are a high quality, manufactured and engineered USA product. Here's a little history of the product line. Back in 1995, the product line was first developed in Flagstaff, Arizona, where I'm talking to you from now, with the Air 303 by Andy Cruz and David Calley from Southwest Wind Power. Then they came out with the 403, little upgraded version 3 years later. And then the Air X and Air 30 in the 2011 time frame. That was the Air 30. And then the Air Breeze and Air 40 was launched around that little bit after 2011. And then now we have the Air Silent X, which incorporates these blue blades, so which we'll talk about here in a minute. So lots of history of this turbine for upgrades and improvements. Lots of turbines out there, parts and pieces you can get anywhere, pretty much anywhere in the world. We have authorized service distributors all over the world. We have 9 of them all across the world in Europe and New Zealand and Australia and so on, Canada. And so have them in Latin America, all over the world, so that if there is a problem with the turbine, it's not an obscure turbine. It's been around for a long time, thousands and thousands of units out there. So here is that Air Silent X we talked about. It has this blue carbon fiber hand-laid blade set, very, very nice blade set. The key to this blade set is it's very quiet. It's quite stiff. It also has aerodynamic trips on the leading edge of the blade set, which make it quiet. A lot of different features that make it quiet. And it's mostly used in our cruising sailboat market where you need a quiet turbine. So the Air Silent X, if you need a quiet marine grade turbine, that's the turbine to buy, the Air Silent X. You can upgrade any of our turbines to this quiet blue blade set. So if you needed an industrial turbine, like the Air 30 is our industrial land turbine, if you needed a industrial turbine for a high speed, very high wind speed industrial application, but you also needed it to be quiet, then you could upgrade the Air 30 with the blue blades and have a very robust industrial turbine that's quiet. So all of our turbines can be upgraded to this blue blade set, which is very helpful. Let's talk a little bit about the turbine itself and the internal components. First of all of our turbines are called upwind horizontal axis turbines. That means the direction of the wind is this way, hitting the nose cone of the blade set first. And horizontal axis, meaning this is the rotational direction. It's on a horizontal axis as opposed to a vertical axis turbine, which you've probably seen before. Most modern turbines that actually produce power are horizontal axis turbines. So, my opinion, they're the ones to get. They have a lot less issues than the vertical axis turbines, and they actually achieve their power curve. Here's the nose cone hub blade set. It is a three-bladed turbine, which is arguably the best number of blades for all-around wind speeds. There are turbines that have 2 and up to 7 to 9 blades, but ours is a three-bladed, most common and most efficient design. Most of the industrial scale turbines now are three-bladed turbines. Here are the bearings right here, and your face that go inside. The bearings go inside the face assembly here. This is the stator. It has the copper windings surrounding it. It's what produces the electrical charge, with the rotor inserted inside the stator and the rotor with the neodymium magnets surrounding the rotor, and that rotates around the stator, again producing the wild AC. That's unregulated wild AC, three-phase AC is what's actually produced inside the turbine. And then that gets regulated up tower in the circuit card right here to 12, 24, or 48 volt DC. And that's what we do. It's all regulated up tower, so there's no need for a down tower controller. Keep that in mind. There's no need for a down tower controller. Everything is done up tower. Our turbines are all voltage specific, so if you have a 12 volt battery bank, you need a 12 volt turbine. It is not interchangeable in the field without replacing a whole bunch of components, including the stator and the circuit card. So you have to buy the specific voltage for the specific system that you're looking for, battery system you're looking for. Right here is the potentiometer and LED harness, and there is a potentiometer screw on the side of the turbine. That's this little thing right here. And on the belly of the turbine, there's an LED light that tells you the functionality of the turbine. All of our turbines have that LED. It's either green or red, depending on the turbine. And that's probably the first question that somebody's going to ask you in tech support, other than the serial number of the turbine, is what is the LED light doing? So you need to know that there is an LED light in the belly of the turbine, and the functionality is, if it's not illuminated, then the turbine, there's not enough wind, or there's not enough RPMs for the turbine to spin up and push amps. If it does become illuminated solid, that means it's spun up above about 450 RPMs and it's pushing amps. If it then begins to blink slowly, that means the turbine is in regulation, meaning that the turbine has sensed the battery regulation voltage set point with the potentiometer. We'll talk a little bit more about that, and it shuts down. And it does that it brakes via electromagnetic braking. It's not a mechanical brake, it's an electromagnetic brake. And the blade set will continue to spin slowly, but it won't push amps. And so that condition, you will see the LED light blinking slowly. If the LED light is blinking rapidly, that means it's an overspeed protection, and that happens somewhere between 30 and 35 miles per hour of wind, and the turbine senses that the wind is too high and it begins to shut down um, to protect itself. It'll then start back up again in 2 to 5 minutes, depending on the control algorithm of the particular turbine. It'll start back up. It'll start to push amps. If the wind is too high, it'll shut back down again. It'll continue to do that automatically until the wind dies down or your battery bank is full. So that is the functionality of that LED light. Okay, so here is a O-ring seal that seals the face to the nacelle. That's the body of the turbine. And then you have the yaw bearing here, snap ring. Here's the slip rings right here, and the yaw itself. This yaw is what accepts the 1.5 Schedule 40 pipe, 1.5 inch Schedule 40 pipe, which is what the yaw will accept. And the wires run down the middle of that pipe. It's a standard Schedule 40 pipe that you can get at a fencing company. It's a thicker wall. It's not your EMT pipe that you get at Home Depot. It's a little thicker wall pipe for fencing and water pipes often. So keep that in mind. Schedule 40, 1.5 inch. That's ID. OD, outer diameter, is 1.875. This is all in the manual, but it's good to remember that. All of our turbines accept that 1.5 inch pipe. The tail of the turbine is there to keep the turbine, as we say, on the wind. So as the wind direction changes, the wind flows over the blade set and the nacelle hits the tail and it pushes it, in the direction it needs to stay for the face to stay on the wind. That's the purpose of the tail. Here are our turbines themselves. Here is the Air Land turbine. This would be the Air 30 and the Air 40 turbine. Those are our land versions. It's a gray cast aluminum housing, a basic finish. And here is the Air Marine turbine. That would be the Air X Marine, the Air Silent X, which has the blue blades. We already talked about that, and the Air Breeze, right? So we also have some different blade sets for the different turbines. I'll show you a slide of that here in a minute. The difference between the land and the marine turbines is all of our marine turbines have a stop switch that comes with them, and all of our marine turbines have this quality marine grade finish. It's a two-part finish, a high painted finish that's corrosion resistant, very high quality aircraft quality paint. That is corrosion resistant for our marine environment. So those are the turbines. All of our turbines are 1.2 meter rotor diameter. They all weigh about 13 pounds. They all will accept this 1.5 inch pipe into the yaw right here. You can see those yaw bolts right there. And the wires run straight down the middle of the pipe. Here is a hybrid system overview. So what we're doing is we're charging batteries, right? So here's your PV system charging the batteries, and separate and working nicely with PV is your air turbine charging the batteries. Two separate systems, two charging resources. Let's talk a little bit about batteries. The minimum battery bank requirement for an Air 30, Air X Marine, or an Air Silent X turbine is about 400 amp hours. That would be here your four batteries, right? 4 100 amp hour batteries, right? 400 amp hours at 12 volts, right? So if you have, that's for an Air 30, an Air X, or an Air Silent X. An Air 40 or an Air Breeze, you can use a smaller battery bank, around a 200 amp hour battery bank, but that's our minimum recommendation for battery bank size. If you're using a smaller battery bank than that, then we need to talk about your loads and all kinds of other factors that will determine why it is that we need that particular battery bank size. And the reason for that is because you can push a lot of amps into that battery bank. And if you have a small battery bank, that battery bank is going to quickly, as you're pushing high amps, say 30 or 40 amps, if you have a 100 amp hour battery bank, that voltage is going to rise very rapidly and the turbine will shut down. And then it'll shut down, the voltage will come back down to resting voltage, and then the turbine will start back up again, and it'll continue to do that until potentially after weeks, months, the circuit card becomes damaged and you have a premature failure in your turbine. So that's why we have that minimum battery bank recommendation, but it really depends on a lot of factors, including your loads. If you have a high load on that battery bank, then that may not even be an issue, but most people would not be in that case. So if you want to know more about that, you can certainly talk to Wholesale Solar, who understands that, as well as you could call us. Here's a standard hybrid wiring diagram. Here you have your PV through your charge controller, right? No charge controller needed for the turbine. It's all up tower. And then you're going through your ammeter, your J box, your fuse breaker, battery disconnect, and so on, down to your battery bank. So that is your solar side. On the wind side, working separately but nicely with the solar, is your turbine. Remember, 3 wires, because you have DC output just like on the solar. And then you're going to go down to your ground. You have your green wire, which is your earth ground. Then you're going to go through a stop switch. Always recommend a stop switch. They are provided with every marine turbine. Ammeter, either analog or digital, is a good idea. Fuse breaker, battery disconnect into your battery bank. So again, separate systems, but working really nicely together to charge those batteries. There is this optional thing that you can do, is a diversion capable charge controller, like a Morningstar TriStar 45 or a C40 made by Schneider, used to be Xantrax. And then you can dump that extra energy into a resistive load like an air heater or a water heater. All that can be done. And if you want to utilize all the power coming from the PV and the turbine, on the turbine side, you turn up that potentiometer screw to a higher voltage so it continues to push amps. Um, and on the wind side, you would set your controller so it does the same thing. So you're constantly charging that battery bank, right? So, and then any excess charge above the regulation voltage set point would then go to the diversion charge controller and divert it to that dump load. So if you want to know more about that, please feel free to call Wholesale Solar. They do provide all those components needed for a diversion load and a dump. So keep that in mind. We did talk about the potentiometer. Here's our settings for the 3 different voltages that we sell: 14.1, 28.2, 56.4, but it is adjustable within this range. Most of our customers don't ever adjust the turbine voltage unless they're going with that system where you can dump the excess power and then you'd adjust it up. Say if you had a 12-volt system and you wanted to dump, you'd set the voltage at, probably 14.6, 14.8, 15, somewhere in there. And then your TriStar would just dump that excess power, right? So that's how that would work. So keep that in mind. Again, most of our customers don't ever touch these voltage set points because our turbine is a bulk charger. And so what we're doing is it's on or off. There's no absorb, float, equalize, any of those charging, finesse charging like your solar does. That does not occur with our turbine. When it sees 14.1 volts, 30 seconds to a minute later, it shuts down, it applies the electromagnetic brake, shorts the windings. The blade set will still spin slowly in high winds, but it won't push amps. Your solar then continues to charge all the way up to that absorb, 14.3, 14.4. It'll do all that last, little bit left charging. We're there just to bulk charge. We're there to get it 95, 97% of the way, and then the solar will do the rest. So that is our purpose. So it is a bulk charger. It is on or off. Here's a nice little thing to have. It's a wind control panel. It includes the analog ammeter, stop switch, and a breaker. Always recommend a stop switch with all of our systems. It's a good idea to have for maintenance purposes, for lots of good reasons. But this just makes for wiring easy, wind in, battery in. So if you're doing your own wiring and you're not an electrician, a wind control panel is a good call because it just makes it easier for the installation. Largest wire this will accept is a number 8, so keep that in mind. Let's talk this little Wind 101 here, right? Let's talk a little bit about tower height. So when you're installing a wind turbine, obviously the higher you can get up, that turbine into good laminar flow wind out of the surface roughness of the ground clutter, the more power you're going to get out of that turbine. And you can see right here going from 10 meters to 14 meters, you're going to get 20% more power out of that turbine. But when you're going from, say, 30 to 45 feet, you're potentially incurring a lot of extra costs in tower, in guy wires, in foundation, in pipe. And does it make sense for a $950 retail land unit? And the answer to that is probably not. If you have to go above 45 feet, if you have to go 50 or 60 or 70 feet to get up in good laminar wind, then you may not have a good site for wind. You may just want to install more solar. So keep that in mind, um, because that micro turbines are different than other types of turbines where you have to get up really high. What you want to have is a good wind resource. We'll talk more about that. And what's even more important than almost as more important than the tower height is siting the wind turbine, right? So where you put that wind turbine on your property, obviously this is the best location for that wind turbine. Okay, you want to put it on the prevailing wind side of any object that's going to cause turbulence, like a building or trees or that sort of thing. You want it to be open to the prevailing wind as far as you can. We have a rule in wind which doesn't necessarily apply with micro wind, but it's a good rule of thumb. We call it 2250. So that's 20 feet above and 250 feet away from any object that's going to cause turbulence. Trees, your your house, etc. 2250. You can't always achieve that, but know if you're not achieving that 2250, then there is going to be a, a degradation of your power curve of your wind turbine. You will not achieve the power curve of your turbine. So keep that in mind. What's really great is when you have a turbine on the water, because you have very little surface roughness, in this case, nice laminar flow. So the lakes, oceans, that sort of thing, great place for wind. Um, Here on a ridge top, as the laminar flow wind moves up the ridge, it begins to compress. So you tend to have really good wind on ridge tops, mountain tops. Obviously, if there's a bunch of trees here, that would make a difference. Something to keep in mind. When you're on a ridge, mesa, plateau, or a building, you're going to have the vertical faces of that building or plateau or mesa, and that's going to cause turbulent wind. That's what these little things are right here, these squiggly lines. That's turbulent wind, and turbulence is the killer of wind power. And so if you're on in that particular situation, you are not going to fully achieve the power curve. So you just got to keep that in mind. If you're on a plateau or mesa, you got to get far enough back behind that vertical face to get back into the laminar flow. And usually you cannot do that on a building, unless it's an extremely large building, but in most cases you can't do that. Um, so you got to keep that in mind when you're doing a building install. That being said, we do have building mount kits because it's usually a very easy installation for a building mount kit. But we do have a couple recommendations. Number one, it's a non-inhabited building. So you put it on your energy shed, your barn, your garage, someplace you're not going to be sleeping, because that vibration of the turbine can cause some vibration into the building, and that could potentially affect you. It could make noise and vibrate the building, especially if it's a small building. Usually large buildings, that's a non-factor, but keep that in mind. And the second thing is when you're installing on a building, you got to also know that the power curve will be affected, and you're going to get less power, less amps out of that unit. So keep that in mind. So we talk a lot about this concept now. It's very popular, the hybrid concept, installing multiple resources into a renewable energy system. When I talk about the hybrid solution, I'm specifically talking about off-grid, because in an off-grid situation, hybrid makes a lot of sense, right? Because you don't have the grid to back you up for at night and so on. You have to have another charging source if your battery bank is not sufficiently charged, and often that's a generator, and generators are very expensive power. So that's why a secondary charging source like a wind turbine makes a lot of sense. I do love solar. It's on my house in Flagstaff, but solar does have some drawbacks. Solar has low output during the winter months. We all know that, right? The sun is lower in the sky, there's less sun hours, there tends to be more weather, etc. Solar has diminished output during bad weather, and we know that you're going to get some output from the solar, but it's going to be diminished. And obviously, no output at night as of yet. Haven't figured that one out yet. So that's where wind power comes in, because the average wind speed is higher during the winter months here in North America. Air density is higher, and air density is part of the wind power equation. So if we can just check this, geek out for a second on this wind power equation. So the three factors are air density, wind velocity, which is cubed and swept area, and air density. The for lack of a better term, the thicker the air, the more power you're going to get out of the wind. So that's important. Obviously, velocity, wind speed is the most important because it's cubed and it's exponential. But the other one is swept area, how big that blade set is, right? So all of our blade sets are 1.2 meter, that's 46-inch rotor diameter. Um, so the bigger you get that blade, the generally the more power you're going to get out of that wind turbine. So keep that in mind. So, and the next one is wind is stronger during the bad weather periods. So when there's weather, there's wind. That does hold true. And our turbine does produce at night, and we often have wind at night. So this comes down to this concept that hybrid systems are complementary, right? Solar, lots of solar in the summer, not a whole lot of wind. You ever notice that? There's not a lot of wind in the summer months here in North America, right? Unless you're in the Caribbean, right? Or the Bahamas. We in Flagstaff have monsoons, and so we get maybe an hour or two of wind in the summer when the storm is blowing in, and then it dies down for the rest of the day, generally speaking. But in the winter months, it's different, right? You have more storms, you have higher wind speeds, and you have a whole lot less solar. And so that's the idea that Mother Nature is telling us: if I have an off-grid system, we should combine wind and solar together. Makes a lot of sense. Here's a wind resource map, a winter wind resource map. At Primus, we focus on only winter wind speed because that's when you need the help in your off-grid system. Your solar is doing all the heavy lifting in the summer months. Um, Only time you really need help on the for the batteries in the summer is when there's a storm period, and then your turbine is going to do the heavy lifting. But generally in the summer, your batteries are going to be charged up. It's in the winter that you need the help, right? And in the winter is when you have the stronger winds. That's just how it works in North America. And so you can see here, the middle of the darker the blue color, the higher the wind speed for this map. And so here in the middle of the country right here, we have a lot of great wind. This is why all the industrial scale turbines are located in Texas and Oklahoma and so on. On the coastlines, lots of good wind around the lakes, right? You have a lot of good wind. Mountaintops, that's what these are, these islands of wind here. So there's lots of places all over the world where you have a good wind speed. And that's what you need to know. You need to know what your wind speed is in your area. Well, how do you do that? We have a tool that we use. It's free for Wholesale Solar and our customers. Wholesale Solar can access this tool for you guys. You just need to provide your address if you have one, or decimal data coordinates, or GPS coordinates, or Google coordinates for your site. We prefer decimal data coordinates if you can get them. You can usually translate those from GPS or Google, or an address. That's super easy as well. And then we provide you with wind resource assessment. That's a 2-page report that tells you what your average monthly wind speed is, and what you want to have is 4 meters per second or greater of winter wind. You also want to be open to the prevailing wind, right? You want to site it properly. You want to consider the tree cover, want to consider your turbulence, where you're going to mount the turbine on a building and all that. But it's a really good starting point to know if you're a good candidate for a hybrid system. And again, 4 meters per second or greater is the recommendation. If you're a little bit below that and you just want to make sure that you have that secondary charging resource, then it's understandable, but that's kind of where you want to be. Here is what a wind resource assessment kind of looks like. It's It's nicer than this, a little more detailed, but we provide you all this data, provide you the monthly distribution. This is my house in Flagstaff, Arizona, and here is the turbine location. That's where that little dot is. You can see that I'm kind of not doing so great. I'm close to 4 meters per second for my winter wind. You can see January, February. Here's November and December. Here are the 12 months of the year. And here, this is in meters per second. So I want to be right in that 4 meters per second. By the way, that's about 10 and a half miles per hour of wind is 4 meters per second. So you can see here, and this is at the tower height of 45 feet. That's what this indicates, 14 meters, 45 feet. And so it gives you all this good information here, uncertainty and the Weibull and the air density and everything. So in this particular case, right, I would kind of be on the edge of whether I'm a good candidate. Here is the wind rose for that site, and that's what you need to site the turbine. So make sure when you get the report, you pay attention to the wind rose, and when you purchase your turbine, you want to make sure you're in the prevailing wind direction. This is more specifically called a power rose, meaning it gives you the power in the wind, and most of my wind is coming out, most of the power of my wind is coming out of the southwest. I have a little bit here in these other directions, tiny little bit to the northeast and east, but I would want to set my turbine open to the prevailing wind, which is coming out of the southwest, which is predominant in North America. Here's another site, much better wind resource, again at 45 feet of tower height. Here's your output during the 12 months of the year. You can see that, right? The curve right there, right? Better in the winter, not so good in the summer. Um, Again, good site here, well above 4 meters per second. Here's the same site at a lower tower height. This is at 10 meters. You can see how it dropped down a little bit. The wind speed dropped down because you're on a lower tower. And then here is that same site, but gives you the wind rose, right? So here it is. It's all the way from the south to the north with the predominant power in the wind coming from the west northwest. And so you want to be open to this direction, which obviously this site is, because here's the turbine. He's open all the way from the north to the south. So this is a great site um, for wind. And obviously it's on the water. There's a lot of good characteristics for that site. So we talked about this idea of when there's weather, there's wind. And so we looked at 30 years of NREL data and at the 240 NREL sites across the country. And we concluded that it is actually true when it's less sunny, it tends to be more windy on average during these bad weather conditions. It's more pronounced in places like Rapid City, South Dakota, with a 23% improvement. But also in Texas and Wyoming, it's also a factor that you're going to have when the storm is blowing in, and it just kind of makes common sense. When that storm is blowing in, you are going to have more wind. So something to keep in mind. Here is the actual complementary curves, excuse me, using NREL data for 3 sites across the U.S. We got Montana, North Dakota, and Minnesota. This is the most pronounced. You can see January through December and how, the red is the wind and the blue is the solar, how much this is a really obvious complementary curve here of the wind and solar resource. So it does make a lot of sense. It's a lot more erratic in North Dakota and Minnesota, but generally on average, you're going to have much better wind speeds in the winter months and be able to help that battery system to last longer. This is kind of obvious. I think most of the people would say they understand this, that the solar day is very different from June to December. That's why most folks will size um, systems for December 21st, the shortest day of the year. And and so, but when you're talking about a hybrid system and being able to have that input in the winter months, that whole sizing paradigm for off-grid changes drastically because you're sizing the solar for December 21st. You are essentially saying that this is the worst day of the year, so you can so you can downsize potentially the solar, the racking, the days of autonomy, the battery bank if you have a wind turbine in the paradigm, in the mix, because you know you're going to be getting amps into that turbine at night during storm periods, during the winter months. So it really changes the whole idea of how you size off-grid systems when you have that secondary charging source such as a wind turbine. But it's very different from June to December, obviously, as you can see in this diagram. Also, with the wind turbine, you're going to have potentially 24 hours of charging into the battery bank, which is interesting because there's some studies coming out, and in my conversations with battery manufacturers, there is some data to support the fact that if you have a more consistent charging resource into your battery bank, that is better for the battery bank, even if it's just a trickle charge of a half an amp or 1 or 2 amps. That consistent charging into the battery bank as you have a load on the battery bank is really good for the turbine, because if you have a solar only system, you're only going to be charging say 4 to 6 hours a day, and if there's a storm period, it could be shorter, winter months and so on. So you have to get all those amps into your battery bank during that relatively short period of time. But with a secondary charging source, if the wind is blowing, you're obviously putting amps into that battery bank to help that battery bank last longer. And nighttime is one of those times when your battery bank, loads are off and on at night, right? Lights, all the things that you need at nighttime when most people are home, they're using the loads in their house. So it's important to have that charging resource at night as well. So it's all about keeping the battery bank happy. This is a Trojan brochure of battery bank discharge. And this is actually a little bit of an older brochure. Most battery manufacturers now only recommend a maximum 80% depth of discharge, not 100%. Because if your depth of discharge is this low at 100%, then basically your battery is dead, and it's going to be very difficult to get it back due to sulfation. So 80% is what's typically recommended for max, and what systems are designed it for is 50%. But if you can get that um, that rate in the 30 to 40% max depth of discharge, if you can get it in here, you can greatly extend your battery life. Because look, you're going from, and these are just different battery types, AGM, flooded, gel, etc. But if you go say from 1,000 cycles to 2,000 cycles here, right? Then that's multiple years difference um, between a solar only system versus a hybrid system. And that makes a lot of sense because batteries are expensive. They always fail at the absolute terrible, the worst times. And so to keep those batteries happy is really critical in an off-grid system. So here's the power curves. Any turbine worth its salt is going to have a power curve. This is a power curve versus this, which is an energy curve. And let me explain the difference. A power curve is instantaneous power in watts. And that's how wind turbines are rated. And this is important for you to know because you see, oh, this turbine is rated at 600 watts. This turbine is rated at 400 watts. Um, the AirX Marine, and Air Silent X is rated at 400 watts. The Air Breeze and the Air 40 are actually rated at 160 watts. So people think, oh, I want to buy the higher rated, higher wattage output turbine. But you really need to understand that that rating is just instantaneous power at any particular second in the power curve. It's just watts. Really what you should be looking at is power over time, which is the energy curve. Um, so it really depends on what you're looking to do with that turbine. This power curve here is the red is the Air 40, the Air Breeze, the blue is the Air 30, the Air X Marine, and the Air Silent X. And you can see actually the Air 40, the Air Breeze will outperform the Air 30 at the lower wind speeds, which is exactly what those turbines are designed to do. If you want a turbine that's quiet and is in a low to moderate wind speed environment, the wind doesn't blow hard there, then the Air 40, the Air Breeze is the way to go. If you have, you don't have really strong high winds and you need a quiet turbine, the Air 40, the Air Breeze, even the Air Silent X is a good way to go. And you can see by the power curve, it's gonna actually do better in those low wind speeds. And it's because that particular turbine is designed, it's got a different blade set, a wider blade set. It's designed to do better in low wind speeds. But at the higher wind speeds and higher RPMs of the Air 30, the Air X Marine, you're going to do better. And that's why we recommend the Air 30, the Air X Marine for industrial environments, high wind environments like offshore, high wind sites for oil and gas, telecom, places where you could see 60, 70, 80 miles per hour wind, because our Air 30, our Air X Marine turbine is very robust. It's designed as our industrial turbine, and it can output higher wattage instantaneously. So you can go up well above 400, whereas the Air 40 Air Breeze is at maxes out right around 200 to 250, right? So so you really need to know your wind resource and what you need from that turbine, and also the sound output, because the Air X and the Air 30 is loud. But if sound is no concern because you're at an industrial site, telecom, oil and gas, etc., then the Air 30, the Air X is likely the best way to go. So certainly we can talk to you more about that if you have questions on that. But really, energy is what you need, energy over time, not instantaneous power. And that's how turbines are rated. Unfortunately, here in the United States, we at Primus are trying to change that. Turbines in Europe and other places are rated by their rotor diameter, but and not rated power, which can be fooled with. So really, power over time is what you want to look at, and rotor diameter. So here's the power over time curve, the energy curve. And again, you can see the Air 40, the Air Breeze does a little bit better than the Air 30 in those low wind speeds. And these two curves, these two lines begin to converge as you get up higher into the wind speed. So that's the difference in an energy curve, and that's why it's important. The last thing I want to talk about before I show you a bunch of pictures is maintenance. And so on our website, under the support tab, primuswindpower.com, under the support tab, if you go down to maintenance and repair, you're going to see a great video on maintaining our turbine. And it's really very simple, and there's really not much maintenance involved. We build a quite robust, reliable turbine. We do that purposefully because we know that the turbine is going to be in very remote locations, and we also know that solar is very reliable with little to no maintenance, and so we have to compete with that. So really the only maintenance for our turbine is you have to check the blade set about every year and a half or so, see there's no significant chips, dings, or things like that. It is a balanced three-bladed set, so if you have a chip in one of the blades, significant chip or a crack, you will need to replace the whole set. Blade sets are fairly affordable, $120 retail for a standard black blade set, molded set. The blue blades are more expensive. They're more like $350 because they're carbon fiber hand laid. Then you also need to check your blade bolt connection to your hub and your yaw bolt connection to the tower pipe, and make sure those are all nice and tight. And that's really, in terms of maintenance, that's all you really need to do. In terms of long-term maintenance, I will tell you that the stator, the rotor, 20-year design life plus. We've seen those things last 20, 30 years. I mean, long time. They're very robust. The 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 things that fail after 7 to 9 years on the turbines are the bearings. So you have to replace the bearings, the circuit card and brushes that because it's power electronics will begin to fail, and then as I talked about, the blades will 7 to 9 years. So those are really the three maintenance items: the blades, the bearings, and the circuit card. The bearing set is like $50 for the yaw and the face bearings. And the circuit card for a full replacement kit, which includes a circuit kit, brushes, new O-ring, a few other items in there as well. That's retail $240. So really relatively inexpensive to repair the units if they do have a problem. And they, like I said, last 7, 8, 9 years, some even longer, depending on the environment, how corrosive the environment is. There's a lot of factors there, but that's the maintenance cycle of the turbine. So here's a 45-foot tower kit on this turbine here in this small cabin operation. You can see the 8 guy wires and the 1.5 Schedule 40 pipe. It's a 45-foot kit. That's the tallest tower kit we sell. In terms of towers, guy wires are the cheapest and best way to go. Our kits do not include the pipe. So you source the pipe locally, but it's a really inexpensive way to go if you're okay with the guy wires coming down. Here's another guide wire kit at a remote location. Very remote location, as you can see here. Great wind location, though, obviously. Solar, or excuse me, this is a marine application with a mast and stay kit here, 11-foot mast and stay kit on this beautiful sailboat. Another beautiful sailboat. Here's the turbine here up on the mast right here. A couple turbines with solar right here on this sailboat. This is a parking lot light configuration with the turbine and the solar combined together to power this parking lot light. The one issue with this picture is that this parking lot light is very close to this turbine, causing some turbulence. So you got to obviously keep that in mind when you're installing solar on the same tower as your turbine. So just something to keep in mind. Here is industrial applications, oil and gas in this particular case. Very short towers, but these are West Texas, Oklahoma, North Dakota, Eastern Colorado, places that have great wind resource. And so generally, because there's very little turbulence, except the cows wandering around, then you don't need to be on a very tall tower. So that's something to keep in mind. In fact, many of our industrial sites, the towers are 15 or 20 feet. Generally, our sweet spot is somewhere between 30 and 45 feet for a tower, but it really depends on your wind resource and the surface roughness of the site. Here is a nice hybrid configuration. It's a pallet that's movable. It has the whole kit in there with the batteries, the solar. This is a Roan self-supporting lattice tower with the stub pole of the 1.5 Schedule 40 pipe for the turbine themselves. Nice little system. This is a mining application here. We do a lot with mining. This is an airport application where they need scare away the birds and that sort of thing. So that's what this is for. Here is Antarctica. This is a science station at the bottom of the world. You can tell that by the vertical solar panels. Multiple wind turbines. Obviously a very high wind site here. One thing I want to point out is when you're doing multiple turbines, you got to make sure that the upwind turbine doesn't shadow the downwind turbine, so it needs to be a different elevation, so you don't have that downwind shadowing effect from the upwind turbine. Something to keep in mind when you're doing a multiple turbine installation. Again, here, 2 different elevations here for these 2 turbines, solar and wind on this buoy platform. Here, telecom. Doing a lot with telecom these days because of the fact that the power consumption for telecom has come down greatly. So they can power up their sites, their remote sites, with solar and wind often. Railroad application here, positive train control. They used to power up these remote sites with propane generators. Now they're predominantly using solar and wind, and makes that generator time a lot less, saves them a bunch of money. Here is a beautiful palapa here in the Sea of Cortez and this Westphalia hybrid system for this VW. I just like this picture. And then here is Alaska. Wind turbine doing really well, but solar panel not so much. Quite iced over. So lots of good stuff there. And thank you for listening, and thank you for being a part of this webinar today. So Wholesale Solar would like to provide a special offer for you, basically 10% off on any Primus air turbine, the Air 30 the Air 40, the AirX Marine, Air Breeze, and Air Silent X. And if I could just review one more time, the Air 30 is our industrial land turbine. The Air 40 is our more residential turbine for low to moderate wind speed applications where sound is of a concern. The AirX Marine is our marine industrial turbine for offshore buoy platforms, things like that. The Breeze is designed for marine applications. It's again a marine turbine that is for lower wind speed applications. And then the Air Silent X is our cruising sailboat application where you need to have those. That's the one with the blue blades, and it needs to be very quiet, often in a cruising sailboat situation that you can do that. And again, I would remind you that those blue blades are compatible with any of our turbines. So all you need to do is use that coupon code WIN10 when ordering, and this will be available for 60 days from today, which would be in 60 days. That would be June 30th. It's May 2nd today. So um, that is the offer from Wholesale Solar, our distributor. And so if you have questions, feel free to contact Wholesale Solar. Um, and there's their contact information with their email and the website. They have an amazing website that provides a lot of information for you. I want to thank you again for being on the webinar today. We will take some questions, but I'm going to stop this recording now. And again, please reach out to us with any follow-up questions that you might have about the Primus Air wind turbine and this hybrid concept. So again, have a great day. Thank you so much. Hopefully this was informative for you.